NASA's experimental supersonic aircraft, the X-59 QueSST, quiet supersonic technology, has finally taken to the skies for its first successful test flight, marking a monumental milestone in aviation history. This achievement is not just a triumph for NASA but also a glimpse into the future of commercial air travel, one where flying faster than sound could become a quiet, efficient, and everyday reality. The X-59 project is the centerpiece of NASA's mission to bring back supersonic passenger flight, which has been absent since the Concorde's retirement in 2003. However, unlike the Concorde, the X-59 promises to solve one of the biggest challenges that doomed previous supersonic airliners, the deafening sonic boom. When an aircraft breaks the sound barrier, it produces a thunderous shockwave that can rattle windows and disturb communities below. This is why supersonic travel has long been restricted to over-ocean routes. NASA's goal with the X-59 is to eliminate the boom and replace it with a gentle thump, quiet enough to fly over land without disturbing people on the ground. The aircraft's first flight took place at Edwards Air Force Base in California, a historic site for many of NASA's greatest aeronautical achievements. The X-59 soared gracefully over the desert, reaching subsonic speeds on its first outing, while engineers gathered vital data on its performance, stability, and control systems. Built in collaboration with Lockheed Martin's Skunk Works, the X-59 has been in development for years. Every inch of its sleek, needle-like body is designed for one purpose: to shape and control sound waves. The aircraft's long, slender nose stretches over 38 feet, making up almost a third of its total length, and plays a critical role in spreading shockwaves to minimize noise. The cockpit sits unusually far back on the fuselage, with no traditional forward-facing window. Instead, the pilot relies on a digital vision system, a cutting-edge combination of cameras and displays that provide real-time visuals of what lies ahead. This innovation not only improves aerodynamics but also represents a leap forward in how future aircraft might be designed. The X-59's flight confirmed the effectiveness of several new technologies developed for the project. Engineers monitored its flight stability, engine performance, and telemetry systems to ensure that all critical components functioned as expected. Early reports suggest that the aircraft handled precisely as predicted by simulations. Over the next few months, NASA plans a series of additional test flights. These will gradually push the X-59 to higher speeds, eventually reaching Mach 1.4, or about 925 miles per hour. The key focus of these tests will be measuring how the aircraft's design shapes the sound waves as it breaks the sound barrier. NASA's ultimate goal is to demonstrate that the X-59 can produce a quiet sonic signature, a low, muffled thump instead of a disruptive boom. If successful, the agency will fly the X-59 over select U.S. communities starting in 2026 to collect feedback from people on the ground. This feedback will be shared with international regulators such as the Federal Aviation Administration, FAA, and the International Civil Aviation Organization, ICAO. The data could lead to new noise standards, paving the way for commercial supersonic flights over populated areas, something currently prohibited by law. The first flight also symbolized the revival of human ingenuity in high-speed aviation. After decades of silence in the supersonic passenger realm, NASA's X-59 signals a turning point. It demonstrates that technological limitations can be overcome with creativity, precision engineering, and persistence. Lockheed Martin engineers worked tirelessly to perfect the X-59's carbon composite airframe, integrating lightweight materials that can withstand the immense pressures of supersonic speeds. The aircraft's single General Electric F414 engine, the same type used in F/A-18 fighter jets, provides the necessary thrust while maintaining efficiency and reliability. Perhaps one of the most remarkable aspects of the project is how it bridges the gap between aerospace research and future commercial use. NASA's work is not just about breaking records but about laying the foundation for a new era of sustainable, fast, and quiet travel. Imagine flying from New York to London in under 4 hours, or from Tokyo to Los Angeles in 5, all without the noise complaints or restrictions that plagued past supersonic jets. This is the vision driving the X-59 mission forward. The success of this first flight is a testament to decades of research into aerodynamics, acoustics, and flight simulation. NASA's earlier programs, such as the State Route 71 Blackbird and X-1, helped shape the knowledge that led to today's achievement. The X-59 stands proudly in that lineage, combining heritage with innovation. The aircraft's data systems are equipped with an array of sensors and microphones to analyze shockwave patterns in real time. These readings will help engineers refine their understanding of how to distribute air pressure and noise energy along the aircraft's body. NASA emphasizes that this isn't just a technological demonstration, it's a human-centered mission. By involving communities directly in the testing process, the agency aims to build public trust in supersonic technology and ensure future aircraft are welcomed rather than feared. The pilot of the maiden flight, Nils Larsen, described the experience as a glimpse into the future of flight. He noted how smoothly the aircraft performed and how its control systems felt intuitive. Despite its experimental nature, every successful flight expands the confidence of NASA's team. Each moment in the air adds to a growing body of data that will inform the next generation of quiet supersonic transports. The agency's long-term vision extends beyond the X-59 itself. NASA hopes private aerospace companies will use the lessons learned from this program to design their own commercial supersonic jets. Several startups, including Boom Supersonic, are already watching the X-59 program closely. Environmental impact is another central concern. The X-59 is designed to explore noise reduction, not fuel efficiency, but NASA is also studying how future supersonic aircraft could run on sustainable aviation fuels, SAF, to reduce emissions. NASA's leadership hailed the flight as a historic step toward reimagining air travel. "This is what innovation looks like," said Bob Pierce, NASA's Associate Administrator for Aeronautics. The X-59 is not just a research plane, it's the first step toward a new generation of quiet, fast, and efficient airliners. The success of the X-59 will depend on how well it can demonstrate its quiet boom technology in real-world conditions. If the community tests show that the noise is acceptable, it could change aviation regulations worldwide. The implications stretch far beyond speed. Supersonic travel could redefine global business, tourism, and connectivity, making distant destinations accessible in half the current time. It could transform how the world moves, communicates, and trades, but NASA is also clear that such progress must come with responsibility, reducing not just noise, but environmental impact, fuel consumption, and carbon emissions. Supersonic travel must evolve sustainably to truly revolutionize flight. For now, the X-59's first successful flight stands as a symbol of human ambition reborn. The quiet thunder that once echoed only in dreams has finally been heard softly, precisely, and beautifully in the shimmering skies above California. The X-59 didn't just fly, it whispered a new promise that one day soon, the world will travel faster than sound without breaking the silence. And as NASA's engineers look ahead to the next phase of testing, the dream of quiet supersonic travel for everyone feels closer than ever before.